This is going to be a review of Atom Test Part 1. So the first question was, in which subatomic particle changes to make sodium-23 different from sodium-24? So remember, mass is determined by protons and neutrons, and these numbers are the mass numbers. So if you look at sodium on a regular periodic table, sodium is element number 11. You can see it right here. So protons are 11. The mass is different. Sodium-23 and is different from sodium-24 by one neutron. So neutrons have mass, but they don't affect identity and they don't affect charge. So when an atom absorbs energy, there's a little typo right there I see. When an atom absorbs energy, like in the spectroscopy lab with the spectrophotometers, its electrons, absorbing means taking in energy, so the electrons have to move to a higher energy level. So that was that answer. Because the electron is absorbing energy, it moves away from the nucleus. Kind of like this. I'll show you a real quick picture. So if you have the atom like this, and your electrons are sitting here, it's a little oversimplified, but if you've got an electron there, when it absorbs energy, it goes out, and then it comes back. So absorbing is out, emission is back. So the flame test lab showed the light that came when the electron went like that. And the absorption spectroscopy lab measured the light that it took to make the electron move away from the nucleus. Question number 3. 13, 14, and 10, protons and neutrons make mass, so it's 13 plus 14, so it'll be 27. So you need to be sure you know that protons and neutrons together make the mass. Okay, quantum numbers, everything that I've taught you about quantum numbers treat electrons as waves. Now, you remember back we were telling the storyline that if you see an electron, you change where it is. So if you can't see it, because then you can't describe it, because if you see it, it changed position, so you don't know where it was. So we calculated where the electron probably would be, and so all the shapes that I've shown you treat electrons as waves. They're regions of probability. Okay, the Fox Theater has neon lights in its marquee. When they emit light, what are the electrons doing? Well, we just talked about that. Emitting light, the electron is moving back toward the nucleus. If you have a negative charge, then you've gained a particle that has a negative charge. So what particle has a negative charge? It has gained electrons. If it has a negative charge, you must have added electrons. If you remember the build the atom, when you add electrons, the charge becomes more negative. I guess I maybe could show you that real quick. If we go here and zip down a few weeks ago, this is in General Chem, but it's the same animation that I used with them. So let me see if I can find it. Here it is, build an atom. So if we do building an atom, get this guy going here. So I build this atom, put a proton in, I put an electron in, and you notice that the charge is neutral. The mass is 1. If I add another neutron, it makes a mass 2. So if I add an electron, then the charge becomes negative. So adding an electron causes it to become negative. I've got to find where I was now. There we are. So an atom that has a negative charge gained an electron. Heisenberg's uncertainty principle said that you can't see an electron, because if you see it, you change where they are. We just talked about that. John Dalton was the guy that came up with atoms, the father of modern atomic theory. And that's this choice. How many protons in an atom of 23? Well, since it's sodium-23, sodium, you'll see right in this position right here, has 11 protons. So that's 11. And atoms of the same element that have different masses doing different number of neutrons, that's just a definition, they're called isotopes. So carbon 12 versus carbon 13 versus carbon 14. Those are isotopes of carbon. Next question deals with Niels Bohr. Niels Bohr noticed that the light given off by excited electrons is only made of specific wavelengths, and we saw it when we looked at the light tubes. From this experiment, he came up with the idea that electrons can only exist at certain distances from the nucleus. They're energy distances, and those energy distances we saw came later to be known in the Bohr model of the atom, and the Bohr model of the atom is this model with the rings around the nucleus. All right, if you have a neutral atom of sodium 23, 23 you remember is the mass. So sodium had 11 protons, so if it's neutral, it's also going to have 11 electrons. You can see it right here, 11 protons, so it'll have 11 electrons if it's neutral. How many neutrons would you expect? Well, since it has 11 electrons, or excuse me, 11 protons, but the mass is 23, 23 minus 11 is 12. So you'd expect it to have 12. Electrons that are in the atom has a positive 1 charge. So to make a positive charge, remember what you have to do. If I have equal numbers of protons and electrons, the charge is 0. To have a positive charge, you got to lose an electron, like that. So the number of electrons, sodium normally would have 11 electrons, but since it has a +1 charge, it's lost 1, so it has 10. In a neutral atom, what equals the number of protons? The number of electrons. As long as there's no charge, that means electrons have not been lost or gained. All right, so that was part 1 of the atom test.